Welcome everyone. So in today's session, we are going to continue from where we stopped. Thanks, Rajesh sir. Thank you, Koteshwar sir. Thank you, Rajesh sir. Thank you, Anita ma'am. Thanks everyone. Thanks, Eva sir. Thanks, Ritesh. Yes, thank you. Thanks everyone for joining in. Okay, so yesterday or in the previous session, we were understanding the the final concepts of our linear algebra module, right? So the basics of algebra and how the OLS works behind the scenes. Today we are going to pick from linear regressions, which is the next module, right? So let me go ahead and first guide the people who have recently joined, right? So let me go ahead and share my screen. So before we start, I would like to know how many people have just recently joined, right? If you've recently joined, type R in the chat box, right? Like recent is last 1 month. Okay. Okay, I hope my screen starts sharing. Yeah, okay. So we have hello, Shiva sir, Deepak sir, and Rajesh sir, Koteshwara sir. Yes. And ma'am, can you just specify which month you have joined? Yeah, I was kind of thinking that you were there from the last 2 months or so. Okay, maybe I'm wrong. Oh, that's really nice. Okay, great. So now, to point the people who have just recently joined, this revision hackathon, the format of a revision hackathons is this way, right? So we continue revising the concepts that are covered in the primary lecture done by our primary faculty here for AI, which is Jain sir or Rajiv sir. Okay. So if you see your teachable, so this is how your teachable looks like. So now if you see your teachable, you can start from the beginning, right? If you are finding yourself in between of the sessions and you have not covered a few modules before that, you can start from the module 1 and also join the revision hackathons, right? You can choose to join because currently in the revision hackathon, we are revising. Let's say we are in the linear models. We're just starting the module 4.1, right? So there are two ways to approach this. You can either start from the beginning, that is no problem, because after we complete all of our 7 modules, we're going to start revising from the beginning, right? So that is how this is all going to complete in a cycle. So all the revision hackathons will happen in a cycle, and if at all you wish to attend or be part of the revision hackathon, you can be part of it and also start from the beginning. So there's a first way: watch the primary faculty's lecture from beginning and continue till where we are, or watch the first lecture of, like, for example, if you're watching 1.3, you can also watch the recording of the same in your inner circle. Yeah, so basically the module 1, I think it's been like 1.5 months prior. So we have 3 sessions per week. Yeah, so that is not a problem, Rajesh sir, right? So all of the primary sessions you can start by yourself, and you can also bring your questions to your revision hackathons. For example, if you have a question, say in 1.4, you can still bring it to the current revision hackathon, so the doubts whatever are there can be clarified, right? You do not have to actually wait for the next cycle to start, right? So that is not a problem. So we have many members who also join our hackathons. So the hackathons, they attend continuously and they also come from the beginning, right? So there is less gap for them to catch up, right? So you do not have to kind of worry or try to catch up. You can go at your own pace, right? So this happens in a cyclic way, right? So with that, we're going to begin, right? So today, we're going to start with the 4.1. Just before that, we have left a little portion because of the time constraint in our previous session. So I'm just going to cover up from the 3.4 of what we have missed, right? Okay. So people who have recently joined, and if this is literally your first time seeing the collab file or this interface, do not worry. How this works is whenever you go to your teachable, whichever module you open, in each of the modules, there is a lecture video, right? So if you open that, the private video opens for you. And there is also a collab file, which is the practice notes or exercise, right? So you can open there, and from there click on this open with collab button, and it will open for you in your own Google Drive, right? So from where you can run the program. Okay, so now we are going, if at all you are trying to open the same collab file, you can come here 3.4 and find this particular link, right? The other way around is I'm going to share this link here in chat with everyone so that you can directly open it from here. Okay, great. Now, as we proceed forward, yesterday we have understood like how the OLS functions behind the scenes and how matrix multiplication is core to any bigger model that works. So we have completed till OLS and this particular exercise of the long bones, going back and how it works. Right. So now we also wanted to understand and start with the another exercise, which is the cosine similarity. The objective of the final objective here was to explain cosine similarity and compute the similarity between two vectors, right? So you need not have to have any prior knowledge if at all you want to understand, but it is still good if you want to go from the beginning. So that is not a problem, right? So how many of you attended yesterday's or the previous session so that you've completed understanding how the OLS works behind the scenes? If you have attended yesterday, type A in the chat box. Yes, thank you, Ritesh. Thank you, Vinita ma'am. Thank you, Anita ma'am. Thank you, Gopal sir. Okay, great. So now we have completed till here. And if at all you're just joining today and you're not attended the previous session, also do not worry. This is like a newer concept, which is not related to the previous one. Okay. So now we are looking at one particular challenge here, where first we'll just go into little of, thank you, Ravindra sir. What is the cosine similarity? So you might have heard about the cos theta or the trigonometric value, the element the cos. That is what we are going to look at now. Now, if at all we have plotted a few vectors previously in our yesterday's session, like if at all you have a vector and which has value like say 3, 4, right? So you can use this particular function which says plot dot arrow and give the values for that particular arrow and plot it. When you give this vector variable into this arrow, so what happens is it plots from 0, 0 to, which is the origin, till 3, 4, right? So this is what it does. This is something we have seen yesterday. But if at all you want to see how the vector works in a detailed fashion, now we are going to compare it with others. Like 3, 4, if you plot this alone, this is how this will look. Now we are also parallelly plotting 3, 0, right? To see, now you can see 0, 0 to 3 on x-axis and 0 on y-axis. So that is what it got plotted in this particular way. And if you plot two vectors together, like both of them are 3, 4. So now what is happening is they are kind of collinear or coinciding on each other, right? So this is what is this particular diagram, right? Now, if at all you want to see how the mirror image of the same is, you can see that minus 3, 4 and 3, 4. This is how the graph of it is coming. So basically how it is happening, it is from 0, 0, 0 to 3, 4 and 0, 0 to the vector 2, which is the vector 1, which is minus 3, 4. So this is what is getting plotted here. Similarly, you can plot minus 3, minus 4 with 3, 4. So these are a few graphs before we get into the cosine similarity. right? I hope it is clear how these graphs got plotted. If this portion, the small portion is clear, type C in the chat box. Thank you, Ritesh. Thank you, Anita ma'am. Yes, thank you, Anita ma'am. Thank you, Gopal sir. Now, going into like, we're not trying to go in deeper of how trigonometric ratios were, actually calculated, because we have a function for each of them in Python. So we're just trying to revise or try to overview of understand the overview of the same, right? So now, if you remember, out of all this particular element, which was cos theta, the value of cos theta was in terms of vectors and magnitudes is written out in this way, right? The dot product of the vector a dot b divided by the length of that value a and b, right? So this is how this has the formula of it is there, right? So a dot b by magnitude of a into magnitude of b, which is also known as length of a and length of b in the Pythonic term. The term in Python language for length can also be it can also be called as norm, right? So the numerator is the dot product of the vectors a and b, and the denominator is the norm of a times the norm of b, which is nothing but length of a and length of b, right? So similarly, what we are trying to do here is just remember this, we're going to use this as we proceed forward, right? So now, what is the problem that we are trying to solve here is, for a real world problem, is there are now, if you might have seen if at all there is an article and you want to compare if this article is also is it copied from somewhere on Google or something. So what you do, and you check online, right? So let me go ahead and share that particular reference here. Give me a second. Okay, so I'll share the reference with you. Yeah. So how many of you used this, plagiarism check? Right. So plagiarism checker is basically what this is, like a full-fledged a checker. What it does is it checks if any article is picked up or copied from any previous article. So it will tell us how much this article is similar to another article, right? So let me just go ahead and for example, if I'm just going to take any article, I'm just going to take I'm just trying to use any common known term and trying to. Okay, so this is not enough text. Yeah. I'm just going to check if this works. So now, how many of you have used or came across this plagiarism checker, right? So if you have come across this, type P in the chat box. Thank you, Vinay. Right, so now you can see that significant plagiarism found, right? So what is happening here is this particular article has detected that there are 25 writing issues out of this, right? Yeah, so victim of it for my assignments, Ritesh says, right? So something similar, core of it, a few applications like this use this cosine similarity, right? So now if you see, what is happening is the article is checking more of words, right? So you can see that the word choice and the punctuation, everything is being checked here. And something similar is happening here in cosine similarity. So the challenge here is we have 4 songs, right? So let's just know them by names here. So one of them is by Lennon McCarthy's song, which was titled as, okay, so this, let me just find the names of these. Okay, so I'm just going to find the names of them from here. So one of them was Strawberry Fields. Let's start by looking at the text of Strawberry Fields. And Strawberry Fields is one particular song written by John Lennon, right? Similarly, there are other songs, like for example, From Me was also another song, and In My Life was another song, right? So Penny Lane, another song by McCarthy, right? So now we are trying to see, there was a dispute previously which says that a song was kind of, most of the words of that song were found in some other song as well, right? So we are trying to see if we can tell to an accuracy of percentage of how much of this song is a copy of the other song, right? So what we are going to do is first we are going to create a data frame. So if the problem is clear, so what we are trying to do here is there are like 2 to 4 songs here, and we are trying to compare one song with other song by using this cosine similarity that we have in front of. Yeah, so Ravindra sir, we are going to just try to understand the same here, right? Yeah, so basically how this is a trigonometric function. So basically when we were learning trigonometric functions or something, we were always thinking how these models, like even matrix multiplication, until I came across that particular session, I never knew that matrix multiplication that we were taught is going to be one of the things that is used in the data science or the AI models, right? So sometimes it's surprising that some of the simple things are used in complex models. So that is great. Right. So now, cosine similarity also, helps us in understanding how this goes. So what we are going to do is we are going to take the lyric of that particular song and count all of the words using our Python functions. So basically, Ravindra said, just to summarize or answer your question, what we are going to do is we are going to list out all the words. And first, at this moment, we're not trying to see if the tune is same or something. We're just trying to see if the number of words in any song, is it comparable to the number of words in other song, and trying to know the percentage of those using the cosine similarity. Okay, so I hope that answers. Now what we're doing here is, there is the first song, which is the Strawberry Fields by John Lennon. So how many of you are clear with the problem statement? So if you understood the problem statement, type C in the chat box. Thank you, Ritesh. Thank you, Anita ma'am. Thank you. So now what we're doing here is we are importing pandas, and then in that, so people who are recently joined here, just coming and staying to see what is happening here, we're just trying to it's like a fun exercise we are doing here, but with our own Python functions and modules, right? So what is happening here is, this is the lyrics of that particular song, and this is already there in your Collab file. So if at all you are first time using Collab file, you have to open the link that I have shared on chat or from your Teachable, and then click on first connect here. So when you click on connect here, the Collab file. So this is an offering from Google Collab, and you don't have to install any Python related IDE or any editor on your system, right? You can always go ahead and use it from your browser itself, right? So now after we do that, we're going to click on run here, right? So I'm just going to import. What we have done, we have created a data frame called Strawberry, and then what we have done, we have used this particular dot split function, which is going to give us the words of all of that particular that are there in this particular data frame, all this paragraph is going to split and give us in one particular data frame. So if you see this, I'm just going to remove the head and I'm just going to run it. I can see that the whole of this text is now summarized or listed out in 191 words in one particular column of our data frame, right? So the data frame's name is strawberry underscore data frame underscore df, and the column name is words, right? So we have all the words that are there, right? So this is the first step. And now what we have done is by using our cross table function that we have used previously. So we are just going to do a cross tab and understand the frequency of all of these words so that we know that how many times each of the word is occurring in a particular lyric, right? So I'm just going to run this. So what we are using here is data frame over the cross table in which we are passing words column of that particular data frame, right? So now here we are going to list the name of that particular column as count, right? So the cross table, if you remember, it's going to give all of the fields here along with the columns, the counts here, right? So we are going to get that. So now what is happening, some of the important words are here, like, strawberry is coming 10 times because the name of the song itself is strawberry fields, right? So strawberry fields. Now if you see fields is coming 10, so strawberry fields came together, right? So there are a few things that like a, eyes, or in, is, these are like common words which are not very prominent for us, right? So we have got all of these counts and frequencies of each of the words, right? So we are clear till now, right? So now what we have done after we did this, we kept the strawberry fields data frame aside, and we did the same thing for our penny lane song, right? So there's another song in which the lyrics of that also is being taken here, and the same thing, the dot data frame over dot split we are doing, and we are splitting this particular text into one of the columns words of this particular data frame, right? And in this itself we are directly doing the frequency of the same, right? So we are doing the data frame cross table and having count as one of the column with all of the counts, right? So now we are going to run this and you have all of this, right? So definitely because here it is penny lane, the name of the song, so you can see that the penny lane, the word came out, like the two words came at least 8 times, and there are other words also, so some of which will be common, like the regular words. But now what we are trying to do here is we are going to bring them both together so that it will be easy for us to do our functions over it. So now what we're doing, we're trying to compare strawberry fields to penny lane. So how we are doing, first we are importing from numpy the functions of dot, and we are also from linear algebra of numpy importing the norm, right? Norm is basically the length of the variable or the magnitude of the variable. So now we have taken in dfs, what we have done, we have taken the two data frames, the frequency of strawberry fields and the frequency of penny lane, and we have created another one, a bigger data frame, which is a combination or concatenation of both of these, right? Connected over the columns, right? So now if you see what will happen, if you remember, we have done merging in our initial sessions where both of two or more columns or two or more data frames connect together. So something similar we are doing, concatenating both of them, and we are listing all of these fields here. So for example, what is going to happen? All of the fields from first the strawberry fields and penny lane, both of them are going to get listed, and wherever they are common, like for example, the word I or the letter I came in one of these 8 times, the other one 2 times, but fields came in the strawberry lane 10 times, but so strawberry fields 10 times, and it did not appear in the penny lane, right? So wherever it is common, you can see that those words are listed in both of the data frames, right? So there are more listed, but here we have printed for us for our assessment, right? So we have concatenated both our columns into single all words data frame, right? So if it is clear till now, type C in the chat box. Okay, thank you so much, Ritesh. Thank you, Vinita. Okay, so now we have added them. Now, what we are doing here is, because there are a lot of thank you, Deepak sir, thank you, Ravi sir, thank you, Gopal sir. We have a lot of nans. Nans, for the people who have recently joined, it is short for not a number. So now this will not be helpful for us to do any kind of assessment. So what we are going to do is we do something called fill NA. Whatever nans are there, we are going to replace them with zeros. So we are going to do the fill NA with 0. So wherever there is a nan, they are going to be replaced with 0. And because we did not have the name labels, because both of the labels here came out as count and count, we wanted to standardize, and we named the columns at strawberry fields and penny lane, right? So now it becomes a little more easy for us to differentiate between, okay, these are the words from strawberry fields and this from penny lane. A few words wherever it is common present in both of them, and wherever it is not there in one of, like for example, if there is a 0 here, means it is there in strawberry fields but not in penny lane, right? So now it is a cleaner data frame, right? So now what we do here is we are going to do the cosine similarity, which is going to be this way. Just give me a sec. I'm just going to clear the outputs, right? So now what we are going to do here is we are going to do cosine similarity. We are going to use the function dot over all words of the strawberry fields, the column, and from the all words data frame, penny lane column, right? So we are going to do the dot multiplication of both divided by the norm of the first into the norm of second. So if you see, this was the formula that we were discussing initially, right? So now if you see the cos theta is the dot product of A and B divided by the norm or length of A and the norm or length of B. Okay, so now we are doing the same here. Okay, so where were we? Give me a second. Yeah, so here. So now we are going to run this and we are going to get that particular similarity here, basically the cos theta value of those two A and B values or two columns. Now you can see that. Okay, so I have to run all of them. So just give me a second. Is my runtime connected? Okay, so just give me a second. I guess. Yeah, I'm just going to reload this to see if my functions are all working fine. Okay. It's just getting connected. Okay, so Ritesh. Yeah, so can you see if your functions are working there on your Collab? Yeah, because this is just strange. Okay, so what is the error? Let me just see. Okay, it is working, sorry. Okay, so we were here. Let me just say cos underscore. Yeah, so we were here. Let me just try running this again. This dot is not defined. Maybe I just need to import it once again. Okay. And they should solve it. Yeah, so this happens when you have multiple variables with same names on the same collab file, right? So we have done all of this and calculated the cosine similarity. So now once you come here, so what happened here is, yeah, thank you so much, Ritesh. Thank you, Deepthi. Yeah, no worries. Yeah, so what we are able to see here is when we are taking out the cos of both of these values, you can see that the similarity, the cosine similarity is 0.22, which means the similarity of both of them is 22%. Right. So strawberry fields, we are only doing not by phrases, we are trying to see words over words, right? So we can see that there is 22% similarity between strawberry fields and penny lane, right? So as we go forward and compare it with the other songs, and we see if there is a higher similarity between other songs, right? So if you have understood what we have done till here, type U in the chat box. Yeah, so I think Ritesh, we will be able to plot the vectors, but I don't think we actually take the value out of it, right? Because they are, so the vectors will get printed with any values, but for us, it's not relevant because these are like, we know that these are lyrics of a song, right? The Python will be able to print it, but we will not be able to use it elsewhere. Yeah. Thank you so much, Vinita ma'am. Thank you, Vinita. Thank you, Rajan sir. Yeah, so Vinita ma'am asked, can we do the same with the data frame columns? We're doing the same with the data frame columns, ma'am. Like for example, now all words is the data frame, and we have, because we have concatenated both of these together. So now we are just using those two columns here. The all words of strawberry fields and all words of penny lane, dot product of that, and norm of the string columns. I'm sure that we'll be able to do that, because in a way these were also strings. I mean, if you're asking, will we be able to do it without the numbers, right? So because here we have calculated the frequency. If that is the question, we are working with frequencies here. If you remember, this is NumPy and pandas. NumPy is the numerical pandas. So we'll not be able to directly work with the strings directly. So that is the reason we are calculating the frequency first. Yeah. Hope that helps, ma'am. Yeah. Now let's go ahead and do the same thing. I'm not going to explain all of it in detail. So now we are going to do the same thing. There's another lyric, which is the song, which is from me to you. And we have taken it in the data frame, me underscore df. All of them got listed. And then something similar we are doing with the another song, which is in my life, in the data frame life. So we have taken that. And we are going to do the same thing, the cos similarity of both of them, the dot product of both of them divided by norm of the first divided by into the norm of second. Now, if we do it here, now you can see that penny lane, when we compared it with the strawberry fields, the cosine similarity was 22. But when we are trying to compare it with in my life, the cosine similarity is 35%, which is definitely higher when you compare it with the previous comparison that we have done, right? So similarly, we are going to see how is strawberry fields compared to in my life. There is 29% similarity. And finally, the final in my life with me to you. 33%. So out of this, definitely we can see that there is a stronger comparison or similarity between Penny Lane to In My Life, right? So which was 35%. And you can see that in actual real life also, there is an article on Wikipedia which says there was a little dispute between both of these creators over the songs being similar, where one of the writers said, I did take the inspiration, but not from your song, from a different song, right? So this happened, but now you can see that the cos theta that we normally use in trigonometric values is also helpful in checking similarity of such things also, right? So now if you've understood this, you can type U in the chat box. Yeah, thank you so much. So I would request the people who have joined recently, if you briefly understood this, right? So if you briefly what actually happened, at least the application part of it, if not the individual functions of Python, if you understood what we have done here, type U in the chat box. Thank you so much, Deep. Yes, thank you, Koteshwar sir. Right. So now if you want to understand depth of each of these like data frame, it might actually sound to you something new, but if you go through our previous modules, it will become a lot clearer, right? So I request you to start from the beginning. But if at all you just want to understand, the linear algebra part of it and all, you can even start from the stats module as well, right? So, but I would request you to definitely go ahead and do the EDA, right? So the module 1.2, that will be definitely a lot helpful, because most of the functions that we use get introduced here in 1.2 and 1.3, right? Okay. Thank you. So this concludes our yesterday's balance. Now we'll just go into our 4.1 here. The 4.1 is the fourth module, the first lecture, which is linear regression. Now we have seen here simple, linear algebras, simple linear regression. Now here we are going to get into the linear models of it. This particular exercise is shorter, so we'll be able to club both of them together here, right? So I'm just going to share another collab file here. So the lecture actually is also very short. Now, if you go to the linear models lecture taken by Jain sir, you can see that a portion of it is more related to, so not this one, the linear regression, right? So am I in the right? Yeah, this one. Yeah, so now what happens is here in this lecture, Jain sir is explaining on how to actually, do a little analysis or guess something, in a method which is not just guessing, right? So how to find a particular value out of the data given, right? So how to actually assess any value based upon previous data, right? So now in this, there is, like, if you see a portion of that particular video is the context of what this is. So this particular video, I'm just going to give you an understanding, like this is like a 8-minute video or something. So you can go ahead and watch the actual lecture also for an understanding, right? So in this particular exercise, what is happening is there is a real estate apartment being sold in New York, and this person, what he does is gives a picture and gives it to 3 people, right? So what he does is he gives the apartment picture. Let's say here, this is the picture of the apartment. Okay, let me, this is the picture of the apartment, and he gives it to 3 people, right? So out of these 3 people, this person is a person into real estate. There's another lady who is into real estate, and somebody who is not very, aware about real estate, but they take guesses of each of them based upon only the picture, right? So, so now what we are trying to do is And towards the end, the price is actually revealed by the person who sells it, and they see how much they have been closer to that particular guess, right? So this is what we are going to do here. We're going to revise the same concept, right? So now in this particular linear models session, first what we are going to do is we are going to take that particular data set, right? So now the data set is there in this particular link. So the data set is in such a way which is having such columns, right? Which is the neighborhood, which is the area of the apartment, and basically here condos means the apartment only, like, this has multiple apartments in that, address of it, the zip code, and the total gross SFT in that, and the sale price. So we will be comparing more of the gross SFT with the sale price as we proceed forward. So what we are doing here, let me first go ahead and share the exercise file with you. You can also find the exercise file in the lecture on Teachable, right? So I've just shared it with you. Now, only thing different here is how we have imported, right? Now, normally what do we do here is whenever we import any particular data set, we import directly from the link that is given. Like, for example, in here, so the data set was in a link such as this, right? So which was on the GitHub of Pixeltest datasets and main, and then there is the file name of that file. So basically this is the directory, right? So now what we have done here is there's another different way to reach the same thing. For example, if I'm just going to say longbones.csv, you're going to get the longbones data set, and there is the other data set, today's data set that we are going to use, which is known as the Tribeca. See, we are going to just, instead of longbones, we're just going to say Tribeca, and you're going to get different data set. So what has been done in this particular data set is we have created a variable which is called data path, which is till here, from beginning till here, and we are just going to append or add to the end the name of that particular file. So we have imported pandas as PD, it's same thing. Only way you will see is how we have imported it. So we have a data path, and when we are actually importing, we are just going to say pd.read_csv data path plus Tribeca. So it's going to be a concatenated, and the whole path will come here, right? So we have just done this, right? So if this is clear, like how we have imported, it's the same thing, but in a different way. So if you understood this, type U in the chat box. Yes, thank you, Ritesh. Thank you, Anita. Thank you, Anita. So now we're going to do look at all these ways. We are going to see how we are able to compare two data sets and predict any particular value. So in this unit, what we are going to do is we'll build a learning model with tabular data, and which is going to help us in predicting New York City real estate prices. Then later on, it will also help us in doing other things, which we'll see in our upcoming sessions, right? So you're going to predict New York City's real estate price, right? So we have done the setup of it, all of this, and we have now ready to go ahead and import it. So the context of it, which is being explained in the video also, is also explained here, right? So there is this one apartment, which is 1497 SFT, built in 1852 and renewed in 2009. And all of this is being explained in the video also. If you want to go ahead and watch that, the link to that also is given here. I think this should be the link, right?
You say pre-war to A.
Yeah, so that particular link is here. So you can go ahead and watch it, and same is being explained here, right? So what is the participant 1, participant 2, and participant 3, right? So what of these 3 people have guessed the actual apartment price. The first person guessed it as 15 million. The second person guessed it as 2.2 million. The third person guessed it as something closer to 2.2 million, right? So this was the final guesses by these three people. Now, because these are human guesses and it required real estate expertise. Yeah, so basically it will not affect anyway. So Ravindra sir asks, we are importing in a different way, how it will be helpful. So it's like convenience way. Next time onwards, maybe if at all you want to do the same import from a same directory, you don't actually have to type the whole value every time, right? So you just have to know the name of the file and you can just add it and it will be helpful for you to run it. Yeah, so I hope your question is related to the current module, Vinita ma'am. So what you say is in linear models, we already have the value for the predicted column. I guess you are talking about this column where there is a sale price, right? So just help me understand your question, ma'am. You're saying that this data set already has a sale price, and then why are we predicting something that is already there? Is that the question, Vinita ma'am? Yeah, so basically what is happening here is these three people who the people mentioned in this particular video, out of these three people, there are two people who have real estate experience, right? Now, if at all, and real estate experience of that particular area, they have lived in that Rebecca area. But if somebody tells us to guess what is the value of this 1497 SFT house with so and so windows and so brick walls, and what will be the price, and they ask me or you, I will not be able to give a perfect guess because we don't know the prices there, and we don't know the actual context and what kind of a locality is there. So now what we are trying to prove here is, now these people, when we are saying that these two people have the understanding or expertise, they have been into this field and they know the data, or at least they know, they have worked with that. But for us, what we are doing is we are just taking the data of all the apartments around. And this 1497 apartment that we're talking about, the current apartment that we're talking about, this one is not part of this data set, right? So I'm just going to print this. Now we have a data frame which has roughly 90 rows, and the prediction that we want to do for the price of this particular apartment is not part of it. So basically we are giving our model all of this data and telling that though we do not have the expertise of understanding that context of real estate in that area, because I'm going to give you the data, now try to make a guess, right? If instead of making a blind guess, go ahead and make a better guess, right? So that is what we're doing. I hope this clarifies your question, ma'am. Right, so given you have 90 apartments in that area, and the price that it got sold and the SFT it got sold, will you be able to predict the price of some different apartment? Right, that is the question. Okay, so why are we not calculating residuals if that is the question? Like we were doing the equation of y equal to mx plus c kind of an equation, right? In our matrix multiplication here. Is that the question, ma'am? So when to use this and when to use that, is if that is the question, yes, let me know. Yeah, so based upon my understanding of your question, yeah. Previous regression models. Can you point me out on which model you are specifying, ma'am? Like which previous regression model? Yeah. So if possible, Vinita ma'am, you can go ahead, unmute and ask the question. Maybe you're talking about the simple linear and multiple linear regression, right? So 3.3 and 3.4. Yeah, understood. Yeah. Yeah, I understand your question. So now here, what we were doing, like, so let me go ahead and, just explain. What we are doing here is we are trying to compare when we are trying to do the long bones data set. Yeah, it is defined. So Deepthi, I'll come to your question. So now what we are doing here is we are using the model to give us an equation, and with the help of that equation we are building that model. So that is understood, because here we are trying to work with a model, and if you see here, we are not doing any prediction. We are coming up with a whole new equation which is going to be true for most of the the data sets, the data points in that particular data set, right? So now if you see, we are trying to find this estimated lines equation, and based upon all these plots and data sets that are given to us, right? So this is what we have done, and we have created a module. We're not predicting anything here, right? So now in this particular example of the 4.1, what we are using is we are using a few modules of regression to predict something, right? So there is a small difference, and here we have in detailed went into, so this data was more like on a scientific note, where we were trying to create understand what is nitro and what is the composition of it and all those things. And here it is more or less a simple prediction that we want to make, right? So that is the reason and for this example, right? So it is like we're going to use a different tool for a different case. Here, because we don't have to make a regression equation, we're not using the coefficients and all. So the question here is to predict, right? So that the prediction has to be made. We are not looking to make any model here, right? So if the problem statement is clear, which is there is one person who's trying to sell an apartment, given you have some experience or data about the surroundings, will you be able to predict this new apartment's price? So that is the question. Here the problem statement is different, and here the problem statement was to see if you could make equation or comparison of how the time there is a data set, and how the relatability of one particular variable is there on other variables, right? So we are trying to do it here, right? So how much like, for example, if our problem statement in 4.1 was go and assess how much the sale price is related on the SFT, and let's say the locality, and the other categorical values, then you do something similar to what you did in 3.3. But here is going to be a slight prediction, so we are taking a different approach. Yeah, Shiva said that is fine. So I hope the context is clear now, Vinita ma'am. Right? So there we were trying to do a comparison between columns. Here we are using the whole data set to make a prediction, but that is a very valid question. Yeah. So if this was clear for everyone, right? So others also, based upon the question asked by Vinita ma'am, if this is clear, type C in the chat box. Thank you, Ritesh. Thank you, Vinita. Thank you, Vinita. Right. So now, thank you, Gopal sir. Now, what we are doing is, because we do not have the context and understanding of it, so a data set has been given. Now, this many times happens in real world scenarios also, where companies or teams are being given data sets, and you have to make predictions, right? Here, fortunately, we also know the actual price that, towards the end of the video, that person reveals, and then we are able to compare how different or how far away these people's guesses were. But in real life, maybe you just have to make a guess, right? So probably this should be the prediction for us, and you don't have any real-time things. So you have to wait for the event in future, right? So that is something that we're trying to aware. So both of them are going to use a little of similar functions, but the application is different, right? So now we have this data set, And now what we are trying to do here is try to do the describe function. We used to use this more in our EDAs when we are doing the exploratory data analysis. Now we are going to do the same thing on the sale price because we want to get the assessment, right? What are some important stats about the sale price? Now, if you do that, there are 90 values in the sale price. The mean of all of them, which is the average, is in USD, right? So in USD, it is let's say 3,928,736, right? So this is what is the price here, right? I could say it is 3 million, 3.9 million, right? So this is the mean average, right? So the standard error, the minimum of that, the maximum out of that, like the maximum out of that was 15 million, right? So this is what is the data given, right? So if you give the same thing, the same data set in an Excel sheet to someone, if we ask them to make a prediction, they will try to make the average out of it and then say, okay, maybe that is somewhere closer to this mean. This is what a normal person would do, right? So we are also going to go ahead and check that, right? So now a little of more context has been given here. Now we have got all 90 sale prices, and we see that the average they cost 3.9 million, some less, some more, right? So now what we are trying to do here is we are trying to take the 3.9 million, the guess, because we are trying to predict here. So we are taking that particular guess here, right? So let me go ahead. Clear. So what we are trying to do here is we're trying to guess by the dot mean. We are trying to create a variable called guess. And what we are trying to do here is now this guess is 3.9 million, and we have sale price of each in this particular data set, right? This always happens. Now, where are we? We are here. Right, so this is data set, right? So what we are trying to do is we are trying to take our 3.9 million guess, and we are going to subtract the sale price from the guess. So, and we are going to add a column called error. So we can see that if it is 3.9 is the average. So if we are predicting that the average will be 3.9, how much will be the error? So 3.9 minus 2.8, 1.1 will be the error. So we are going to do that and add it as a column in the same data set. So we are going to say errors equal to guess minus the this data frames sale price. So we are going to do it. Now you can see that this is the difference, the 1.1 million, and all of these differences are being taken out in this errors in a variable that we have created. Now, what we are trying to do is we are trying to take the average of these errors, right? So we are going to just take the average of these errors by doing this variable mean absolute error, right? So we are just going to go ahead and do that, right? Now, what is that value? We're just going to print them here. Now, if we just guessed every Tribeca condo sold for the guessed value, which is 3.9 million, we would be off by, because the error is 2.7 million, we would be away from the actual average, right? Because if you see, we cannot just go ahead and use the mean as a predicted value, right? So now what we're trying to depict here is, if at all we say the guess price for this particular 1497 apartment is 3.9 million, on an average, you would be away from your actual guess by 2.7 million, right? So which is very big of a difference, right? So we do not want to do that. So this is the usual way, right? Which is going to give us a bigger error. So if this is clear till now, type C in the chat box. Thanks, Ritesh. Thanks, Anita. Great. Thanks, Anita. Right. So now we are going to take a different approach, right? So we are trying to get a little bit more on a predictive model, right? Thank you, Ranga sir. So instead of trying to directly guess by mean, we are trying to go and guess with the model, right? So before that, we are just going to plot this, and we are going to use our plotly, and we are going to do the scatter here, right? So now on x-axis, you can see this is the gross SFT plotted against sale price, right? So now what is happening? Yeah, so Deepthi, how the guess was made, which was just based upon a formula, which is nothing but a mean, right? So the dot mean or average. So what we have done here is we tried making a guess based upon the average of the whole sale price, right? So that was it. So now we are going to go ahead and make the model here. Now, before that, we are just going to plot both of them, do the scatter plot using the libraries of Plotly. And now if you see, the SFT and sale price have some relation, right? So if you have an estimated line, that will go somewhere from here like this, right? Because most of the prices are like, as if it is a 1000 SFT apartment, the price is lesser than 2 million, right? So if the SFT is lesser than 1000, the price is less than 2 million, and similarly it goes off, right? So there are a few outliers which says 3000 SFT got sold for 15 million, right? So the gross SFT was 2,964 and the sale price was 15 million. Now this is an outlier. Maybe there could be either it was sold for a higher price, or maybe it is closer to let's say some very good amenity, right? So there's some good locality is there. For that reason, it could be higher, or the view is great, or the some benefit is there. Similarly, there are other things. Now, if you see this, because there is higher SFT, the price higher, this makes sense, right? So now what we are trying to go and do it is, we're going to just add in the trend line by using this particular parameter here. So which is just going to give us a line, the estimated line, right? So we got our estimated line, which is an average distance from all of these scatter plots. So we have done this. Now the y variable, the sale price here, is also called many things, like the dependent variable, the outcome variable, and the x variable is also called the independent variable or the feature, right? So there are multiple names that those have been listed out here just for knowledge, right? So now we have got our graph here. Now what we are trying to do here is we are going to use one of the Skykit libraries to get our model. A little bit more of this is explained here, but now we're going into the model, then coming back, right? So now what we are going to do here is the steps involved is we're going to choose the model, and from the class Skykit learn, and then we are going to use our parameters, and then create our model by using the fit function, which we have previously also used, right? So we're going to use the fit method for our instance, and also going to generate it. And after doing all that, for supervised learning, we are going to use our predict labels by using the predict method, right? So let's go ahead and try it. A little detail of it as we try, that will become clearer, right? So as mentioned, we are using the library, this Skykit learn, and from that we are going to import the functions of linear regression, right? So first I'm going to run that. Then we are going to create, instantiate, or initiate this particular variable. It's not always necessary to instantiate, because you can always do it while you're doing the model. It's just given as a step, because for you to understand, we're going to use the model in this particular format. Now we're going to print both of our data frame columns, gross SFT and sale price, right? So let's go ahead and do it. So we have our SFT and our sale price both in these two columns. So we have all of our ingredients. Now features, nothing but our x-axis, target nothing but our y-axis, fancy names for the same things, right? So we are going to do that, and we are going to train the model, and we are going to create the x train or y train, the names of these variables, nothing unique about these variables. We are going to copy these into these particular data frames. These were initially columns of the same data frame. Now we have separated them. So same thing, same outputs you're going to get. Now what we are going to do is we are going to do model.fit, and we are going to pass the parameters x train and y train, right? So the variables that we have created. So if you remember in our previous session, we did the generate or get b kind of a function, which was a user defined or custom function. Now fit is already an existing function. So we are going to give both the columns as inputs to model.fit, right? So now we are going to generate the model, right? So now what we are going to do, let's go ahead and give the inputs here. Okay, so let me just go ahead and check. What is the error? Call fit was with appropriate arguments. Give me a second. I'm just going to do a usual run. Okay, so first this has been run. Okay, so let's go ahead and see. Okay, so now we are here. We've just applied the model, and then we are going to give the new data. So the prediction is going to be done based upon new data, right? So for that, we are going to use the function defined as predict. So now we have created our model with fit method, and now we are going to give new input to the data. Like for example, if there are 3 people who understand the whole of the context here, and for them, we are asking them to go ahead and predict this 1497 SFT in Rebecca area, what would be the price of it, right? So something similar we are going to do here by using the function called predict, right? So now the new SFT is 1497. We are going to save that in the data frame x test, and the y prediction is going to happen with the function model.predict given the 1497 as the data frame. Now, if you predict, if you run this particular variable, now you can see that the prediction is 3.1 million, right? Which is 0.8 million lesser than the actual mean value, right? So this is what we have done with the functions. So I'm just going to repeat these particular variables, these particular steps of the prediction process. So I hope we were clear till here, the whole of the actual older module. Now coming to the predictive module, we are going to use the scikit-learn to fit the linear regression, and the steps are mentioned here. We are going to run the same thing. So we are going to use the scikit-learn's library here, run the model, give both of the inputs as 2 data frames, features and targets, which is nothing but x and y axis. Now, when you give that input to the model, now the model has some data, right? Out of which it can make a prediction. Then we tell, because model, you have the data, go ahead and predict for the x value of 1497, and then goes ahead and makes a prediction of 3.1 million, which was, which is lesser to our 3.9 million mean, right? So if you understood till here, type U in the chat box. Thank you, Ritesh. Yeah, so if there's any question, you can go ahead and ask. If it is all clear, then it's good. Thank you, Ritesh. So now if you see, there is a different, right? There is definitely some difference. We are not saying that this prediction is accurate. We are saying that this prediction is better than the, wild guess. Yeah, so that is what we are trying to do here. Now in the video, the actual price is being revealed towards the end of that particular video. If you go ahead and see that video, the actual price that was mentioned was 2.8 million, right? So let me go ahead and so the actual price of that particular condo or apartment was 2.8 million, right? And now the three guesses taken by three people is 15 million, 2.2 million, and 2.2 million by two people, and 15 million by one person, right? So now if you try to take the average error that these three people together have made, now if you try to do that here, now we are trying to do the same absolute error. Our model's error is 3.1 million minus 2.8, right? So you can just go ahead and then do a simple function, which is your actual value that you predicted, the model predicted, and the actual price revealed, right? So which is nothing but the difference of it, right? So the difference is how much? Is going to say which is 300k, right? So 300k was the difference in price. Now if you take the difference of these people from the actual price, right? I'm just taking the best cases here. Now you can see that it was 600k, meaning our model was better predicting than the actual, the error in the model was actually lesser than manual guesses, right? So this is what we have done here, right? So if you have understood that our model guessed, the error in the model's guess was lesser than the manual guess. If you understood that, type U in the chat box. Thank you. Yeah, so yeah, thank you, Vinitha ma'am. Thank you. So Ritesh asked, did we do a random split of the train and test? No, we did not. So basically what we have done here is, because our SFT was 1497, we have given that as an input to the model that we have trained. Yeah, so we have not done a random split anywhere. So it was all in the same steps that we normally do for any prediction. Okay, thank you so much, Ritesh. So now now you can see that with the help of this particular function. So anything before this particular graph was a usual method. Now post that, these are the smaller steps. So now whenever you need to predict something, you know how to go ahead about it, right? So now we have used a few functions from linear regression, which is the fit and the predict, by giving the data as an input to this particular model, right? So which gives us accurate results than a random guess or rawly calculated guess, right? So this is what we have done. This brings to the conclusion of today's session. There's more understanding of the same, which we are going to cover in our upcoming session. It's going to be just examples of the same thing, right? So how we're also going to use train the same machine learning algorithms, how we are going to make a predictive model, and how the expected value is coming, something that we have done here and that has been explained here, right? So now this particular learning model, we're just going to see the overview of it, and then we are going to conclude. Now what we are doing here is just trying to take an analogy from whatever we have done here. Something similar is going to happen in the supervised learning model also, right? So you're going to make a model, give it all the inputs, make a good fit model, and then go ahead and give new information, right? So here you are training the model, then you gave a new information, and then you gave the feature. Based upon that, you are asking it to predict a target, and then it gives you an expected label, right? So even the complex modules, the complex models also follow the similar step, but here we have taken a very small example of the real estate data set. Even if some complex or supervised models are also going to use the same steps. That is what we are trying to convey here in this diagram, right? So this concludes our today's linear model 4.1. If at all you have any query, you can go ahead and reach out. Else, you can go ahead and also watch, the actual video, which is given in the same exercise file, right? Or in your teachable, right? So it's also going to give you more context about the same thing, right? So if there's no query and everything is clear, type C in the chat box, which will help us in concluding. Okay. Thank you so much, Ritesh. Thank you, Deepti ma'am. Thank you, Gopalaji sir. Thank you, Vinita ma'am. Thank you, Ravindra sir. So thanks everyone. So we'll see more of this as we proceed forward in our upcoming sessions. The one that we will do it on Tuesday. Right. Thank you so much, Ritesh. Thank you. Thanks for that. Yeah, so go ahead and try out the assignments, and if there's any query, you can bring them to our session in the upcoming session. Great. Thank you. Thank you all. Thank you, sir. So the people who have recently joined, I request you to use the time the next 2 to 3 days. Maybe start from the beginning. Take some little time. Don't try to rush or try to catch up. Go at your own pace, because these revision hackathons are going to happen in cycles. So do not worry about that. For Rajesh sir, ask to go to the course. I'm always going through the mail only. Is there any better way? Okay. So Rajesh sir, you have access to Teachable. Now, what you can always do is you can just go to school.pixeltests.com. Now, if you go here, this is like a model. Now you can see here my enrolled courses. When you click on your my enrolled courses, you have to sign in first. Now to sign in, you have to use your Teachable email ID and password. And once you do that, your courses will appear here. And once you click on the IIT Madras Bronze or Silver or Gold course, you'll be able to see this particular flow here. Right. So I request you to try it out. And if you find any questions, you can always reach out. Thank you so much. So I've shared the details. Yeah, so Anna ma'am, I am going to reach out to you. So I'm directly going to reach out to you to explain that particular question, the slithering question. So I'm also going to, I'm also assessing the test given in that based upon that question. And once I complete, I'll just reach out to you and share with you the details directly. Okay, thank you so much, Anita. So thanks everyone, and see you in our upcoming session. Thank you.